Worksheet 13a, Strain Transformation with Rosette. In order to determine the state of strain at a critical point in a structural member, a strain rosette is used. When the structure was loaded, the following readings were taken. Epsilon A in A directions, 450 micro inch per inch. So micro it means 10 power negative 6 if you recall. Epsilon B 100 micro inch per inch, and epsilon C is 50 micro inch per inch, and the setting of the rosette is on the finger on the right. Determine epsilon x, epsilon y, and gamma xy for this point in the member. So that basically from the equation you do in the rosette. Here 3 equation and 3 unknown, and we can solve for that one. So let's write down the 3 equation here. If you have the epsilon A, and that is 450, so we just go ahead to write the 3 equation from this setting. So epsilon A equal to 450 micro. So basically that is epsilon A, and that equal to epsilon x cosine square theta A. So as you can see here, this is cosine, and that is theta A, and theta B is 45 plus 45, so that is theta B, and 45 plus 45, 90 degree. And then we also have theta C, which is 45 plus 45 plus 60, so it will be 150 degree. So with all of that number, we can plug in here. So it will be cosine 45 square plus epsilon y sine 45 square plus gamma xy cosine 45 sine 45, and of course we have epsilon b equation equal to 100 micro epsilon x cosine square 90 degree plus epsilon y sine square 90 degree plus gamma xy cosine 90 sine 90 degrees, and epsilon c we have 50, and epsilon x theta c 150 cosine 150 degree square plus epsilon y sine square 150 degree. Just consider that degree, everyone. Gamma xy cosine 150 sine 150. And from that 3 equation, we can be able to simplify. The first equation, epsilon f cosine 45 degree square, so that is 0.5, 45 cosine 45 degrees square, it will be 0.5, so I have it 0.5. Epsilon x, similarly we also have 0.5 epsilon y. The next one, it will be 0.5 gamma xy equal to 450 micro, and the next one is 90 degrees, so cosine 90 degrees is 0, so the third the first component and the third component involve cosine 90 is 0. So you only have epsilon y sine 90 degrees squared sine 90 degree 1. So you have the next second equation is epsilon y equal to 100 micro. And the last equation we will have 0.75 epsilon x plus 0.25 epsilon y minus cosine 150 sine 150, that is 0.3433 gamma xy, and that equal to 50. So three equations, three unknown, but as you can see, the second equation you already find out epsilon y, and then you plug to the previous equation 1 and 3 you can solve. So here, without make more complication, we can have solving for this. I have epsilon x equal to 314 micro, epsilon y 100 micro, and gamma xy equal to 486 micro inch per inch. If you want to write down here the unit, it will be inch, micro inch per inch, inch per inch, micro inch per inch. If you also remember here, micro equal to 10 power negative 6 micro. So that is the, because the strain or the deformation very small, that's why we have it for here. Draw the 2D state of strain block. So you have epsilon x, epsilon y, and gamma xy. So you can make a block or the block square, and epsilon x 314 micro and positive, so it going out. This is 314 micro inch over inch, and the other side will have the same number. And epsilon y 100 and also positive, so go out of the plane 100 micro inch over inch. The opposite will be the same. Gamma xy positive 486, so it will be same at the gamma xy in here. The direction and you for the gamma, this is gamma xy, so it 486 micro. Why it go up on the positive x plane? Because the from our calculation it positive, so the gamma xy, x is stand for the plane that gamma stand on. So you can see this is the x plane because it's perpendicular to the x-axis, and then plane divided by the axis perpendicular to it, if you recall that. The y is show the direction of that gamma. In that case, as you can see, positive, so have to show in the positive y direction that y go up. When that go up, the other way have to be going down to make a couple, and of course to be in equilibrium that have to be go that way to make a couple clockwise rotation. So counterclockwise, clockwise rotation, it will cancel out 0. So with that we do for the worksheet 13a. So you apply the equation, find out, and can draw the 2D state of strain block.